Okay, here we are for the last set of homework problems. This is 15 through 22, and we are solving these equations. And the things that make it an equation is that we have our equal to sign. So right here is our equal to sign. That's the difference between just factoring and factoring to solve equations. Now there's some steps that we want to go through in order to solve these equations. The first thing that we do is we are going to set the equation equal to 0. Okay, now a lot of times it will already be set equal to 0, but sometimes it's not. So you have to know that that's the first thing that we do is we set the equation equal to 0. The second thing that we do is we factor. Okay, and sometimes there's 2 factors, sometimes there's 3 factors. I don't think we'll be looking at 4 factors, but that's possible. So you are going to factor the left side of the equation. The third thing that you do is you set each factor equal to 0. Okay, so you set the entire equation equal to 0, then you factor the trinomial or polynomial that you have, and then once you have it broken down into factors, you set each factor equal to 0 and you solve. And at that point, you have the solutions, and you can have multiple solutions. So let's look at the first one that we have right here. We have x squared plus 8x minus 48 equals 0. And so this one is already set equal to 0. And so we're already set equal to 0, so we're going to go on to part 2, which is where we factor. Now this trinomial has a 1 in front of the x squared, so our product for this one, we are only looking at negative 48. So anytime that we have a 1 right here for our coefficient, this right here then is our product, and so it's a little bit more straightforward. So we are looking at negative 48 for our product, and our sum in this situation is 8, positive 8. So because our product is negative, we are looking at 2 numbers. One of those numbers is going to be positive, and one of those numbers is going to be negative. So I'm just going to start listing some factors. I have 6 and 8. That's not going to get me there. 16 and 3, that's not going to be helpful. I have 4 and 12, that potentially could be it. So I could do negative 4. If I had negative 4 and positive 12, that would get me to positive 8. And so these are my 2 numbers that I am looking for. And so because this is just x squared, I'm able to just go ahead and write those 2 numbers down. X minus 4 and x plus 12 equals 0. So I have set the equation equal to 0. Excuse me. I have factored the trinomial. Now I'm going to set each one of those factors equal to 0. So I have x minus 4 equals 0, and I have x plus 12 equals 0. So I set each one of those individual factors equal to 0, and I solve. So I end up with x equals 4 and x equals negative 12. So those are my 2 answers, 4 and negative 12. And that is number 15. Okay, so let's move on to number 16. Number 16. And we're going to solve this the same way. We have 4n squared equals n. Now, the first thing that we have to do in all of these problems is we have to set them equal to 0. So I'm going to have 4n squared minus n equals 0. So what I did is I subtracted that n from both sides. And so I ended up with 4n squared minus n equals 0. So for this factoring, I've got an n in both terms. So I'm going to factor out an n. So I've got my n on the outside, and then I would have 4n minus 1. Okay? Because n times 4n is 4n squared. N times negative 1 is minus n. So I have factored that problem right there. So the next thing that I'm going to do is I'm going to put each factor equal to 0. So I'm going to have n equals 0. So I don't have to do anything else right there. 0 is one of my solutions. Then I have 4n minus 1 equals 0. So 4n equals 1. Then I'm going to divide by 4. And so my other answer is n equals 1/4. So my two solutions to this are 0 and 1/4. Okay, so let's move on to the next one. Okay, so this one, we do not have a coefficient of 1 in front of our x squared. We have something greater than 1. We have 4 in front of that. So that one's going to be a little bit more challenging. So the way that we get our product here is we multiply our a and our c. So we are going to take 4 and we are going to multiply that by 9 to get our product. So our product is 36. Our product is 36. And my sum is going to be negative 12. Okay, now our product is positive, so that means our two numbers have to both be positives or both be negatives. Since our sum is negative, it means they're both going to be negative. So we're looking at two numbers multiplied together give us positive 36 and added together give us negative 12. And those two numbers are negative 6 and negative 6. You know, you could have negative 4 and negative 9, but that doesn't give you the correct sum. Negative 12 and negative 3, that also doesn't give you the correct sum. So the two numbers that we're going to use are negative 6 and negative 6. So I am going to split this term right here. I'm going to split that term. And so I have 4x squared minus 6x plus 9. Okay, and that still equals 0, but we're factoring that process. So now I'm factoring by grouping. And so I'm going to look at what goes into 4x squared and negative 6x. And the answer to that is a 2 and an x. It goes into both of those. And so 2x times 2x gives me 4x squared, and 2x minus 3 gives me minus 6x. Okay, now I am going to look at these two. Now I've got a negative here, so I've got to kind of deal with that, because whatever I factor out of this minus 6x plus 9 has got to be 2x minus 3. So I'm actually going to factor out a negative 3 right here. So negative 3 times positive 2x gives me negative 6x. Then I have minus 3 times minus 3. That gives me positive 9. So my factors here are 2x minus 3 and 2x minus 3. And by this time, you have probably identified that this is a perfect square trinomial. And so what that means is I can write it as 2x minus 3 squared. Now, some teachers want you to be able to identify that and be able to know that that's a perfect square trinomial just by looking at it. I don't think that that's necessary because you can use your patterns in your factoring to factor it. The one thing that you want to know about this is because your two factors are exactly the same, you're only going to have one answer. So we're going to do 2x minus 3 equals 0. And if you do 2x minus 3 equals 0 again, you get exactly the same thing. So here I add 3 to both sides. I get 2x equals 3. When I divide by 2, I end up x equals 3 over 2. I do that again and I get exactly the same thing. So my answer here is just 3 over 2. In this situation, you only have one solution. Now, eventually you will see how that turns into multiplicity and what that makes of the graph. And so there's a lot of things that we can discuss about having one answer to this problem. But what you need to know now is that the solution to this is x equals 3 over 2. Okay, so let's move on to number 18. 18, makes us want to just go ahead and solve this. But we can't. We can't solve this. So it is already factored, but it's not set equal to 0. It's set equal to negative 18. So we can't do anything with that yet until we go ahead and FOIL this n minus 2. It's very, very important that you remember that this has to be 0. That has to be 0. You can't do anything if that's not 0. So here I'm going to do n times n, which is n squared. N times 7 is 7n. Negative 2 times n is minus 2n. Negative 2 times 7 is negative 14. Now at this point, we can move over our negative 18. We do have some like terms, so we have n squared plus 5n minus 14 equals negative 18. So I'm going to add 18 to both sides. And when I do that, I'm left with positive 4 equals 0. And that's what we want. We want it to be set equal to 0. Now at this point, we can factor. Because we've got it set equal to 0, we can now factor. Our product is 4 because this term right here has a 1 in front of it. So all we have to do is look at that 4. And our sum is 5. And hopefully, because your product is positive and your sum is positive, you've realized that both of your numbers have to be positive. And fortunately, 1 and 4 are our only options. 1 times 4 is 4. 1 plus 4 is 5. And so our answer, or our factored form of this, is n plus 1 and n plus 4. So we put each one of those equal to 0. So I have n plus 1 equals to 0, n plus 4 equals 0, and I get n equals negative 1 and n equals negative 4. And those are my two answers for number 18. Okay, so let's now look at number 19. Okay, number 19 has a greatest common factor in it. There is something common to every single term, and it's actually a numeric number as well as a variable. So if you look at your coefficients, I've got positive 3, positive 21, and negative 54. The good news is that 3 comes out of all of those. And so I'm going to have 3 times the number that I'm looking at here is just 1. Then I've got 3 times 7, and 3 times negative, give me a second. So 54 divided by 3, 3 goes into that one time. So 18. It just took me a second. Okay, and then I'm going to have negative 18. But the other thing that I want you to look at is I want you to look at, well, we'll change the color. How about that? Let's pick like a pink. Well, okay. Let's do a pale pink. Okay. Look here. I have an X common to everything also. So I can pull out an X and I'm left with X squared, X, and negative 18. Now, just keep thinking about that 3X on the outside. But now I want to factor this polynomial right here, or this trinomial. So I have x squared plus 7x minus 18. We're not forgetting about this 3x. We're just leaving it off to the side for now. So I'm looking at that negative 18. That's my product. My product is negative 18. Because it's negative, I am looking for one positive number and one negative number. My sum here is positive 7. Okay, so I always think of 3 times 6. So 3 times 6 equals 18. But if I make one of them negative, it still doesn't give me a sum of 7. The other numbers I think about for 18 are 9 and 2. Now, if I make my 2 negative, then that's going to work. So for factoring, my numbers are x plus 9 and x minus 2. So I'm going to rewrite this in fully factored form. So I have 3x times x plus 9 times x minus 2 equals 0. Now, I'm going to take each factor, and I have 3 of them this time, and I am going to put each one of them equal to 0. Okay, so I have 3x equals 0, x plus 9 equals 0, and x minus 2 equals 0. Okay, so here if I divide by 3, I'm just left with 0. X equals 0. Okay, here I subtract 9 from both sides, and I'm left with negative 9. Here I add 2 to both sides, and I'm left with 2. So these are my answers. 0, negative 9, and 2. Okay? Now, the next couple of ones are going to be a little bit more challenging. So let's just kind of take it step by step. There's going to definitely be some trial and error. We're dealing with some very large numbers here. Now, you definitely will have problems on your quiz and on your test that have a coefficient greater than 1 in front of x squared. You will not have something as large as negative 35. I don't think it's fair to ask you to figure out problems with that high of a coefficient and you don't have access to a calculator. So just know that I do intend to be sensitive to that, and I won't ask you to do any calculations that are quite that large. Okay, so there's a couple of things that I'm going to do with this problem first before I really get down into it. The first thing that I'm going to do is I'm going to go ahead and rewrite this in standard form. So I'm going to say here we go. So I'm going to say negative 35x squared plus 13x plus 12. So what I did is I just put that in standard form. Okay, I did x squared first. Now, you don't have to do this. You certainly can. I'm looking for a common number, like is 2, is 3, 7, 5. Is there anything common to all of these? Just so I can make it smaller. Because right now I'm multiplying negative 35 times positive 12, and those are very large numbers. And there's not. 13 is prime, and so there's nothing that I can factor out of this. And so, like I said, these are some pretty large numbers. And while I do want you to be able to work with numbers where your a value or your coefficient in front of x squared isn't 1, it just won't be this big. Okay, so the first thing that we are going to have to do, some people like to divide everything by negative 1. I am one of those people. I like for my a value to be positive. So that is an acceptable thing to do, is to divide everything by negative 1. And you can do that because you've got it equal to something. If I didn't have it equal to 0, it's not a good idea to do that. You're just you're factoring out a negative 1, and that's an okay thing to do. But you certainly don't have to do it that way. I'll go ahead and leave it like this, but just know dividing everything by negative 1 is an okay thing to do. Divide by negative 1 is reasonable. I'm not going to do that, but you can. So we're going to go ahead and we are going to multiply 35 times 12. And like I said, we're looking at some very large numbers. So our product here is going to be 420, or negative 420 is going to be our product. Our sum at this point is going to be 13, positive 13. Okay, so when I start thinking about 420, I can divide 420 by 10. So I'm going to say 420 divided by 10, so that's going to be 42 and 10, okay? I'm not going to be able to get positive 13 out of 42 and 10. So another one that I would think of, 20 is going to go into this pretty nicely. 420 divided by 20 is going to give me 21. So those are not going to be the numbers that I can use. So 20 times 21, that is not going to give me a sum of 13. So let me divide 420 by 15, and let's see what happens if it's possible for me to get anything if I divide by 15. Now in that situation, 15 times 28 gives me a sum of 13. Okay, and so that, or 15 times 28 gives me 420. If I make the 15 negative, then I'm going to get a sum of 13. So these are actually the numbers that I'm going to work with. Negative 15 and positive 28. So what I'm going to do now, and that wasn't as bad as I thought it was going to be because those numbers were pretty big. So now, because we're dealing with factoring something where your A value is not 1, we are going to split this into those two numbers. So I've got negative 35x squared minus 15x squared plus 28x. I'm sorry, that's not x squared. That's just going to be x right here. Okay, so that is 15x right here. Plus 28x plus 12 equals 0. Okay? Now remember, what I've done right here is I've taken negative 15x and positive 28x, and that's still equal to 13x. So I haven't changed the value of anything. I've just split that 13x into my two numbers. So now what I'm going to do is I'm going to look at these first two, and I can take out a negative 5. Negative 5 from negative 35 and negative 15. And then I can also take out an x from x squared and x. So I have negative 5x. Is what I'm taking out of both of those. Okay. I'm sorry. I'm taking out a negative 5, and then I'm left with 7x plus 3. Negative 5 times 7 is negative 35. X times x is x squared. Negative 5 times 3 is negative 15. X times nothing is our x. So negative 5x times 3 is negative 15x. Okay. Now, here, I can take a 4 out of both of these. So I'm going to have plus 4. So 4 times 7x gives me 28. And 4 times 3 gives me 12. So my factors are negative 5x plus 4 and 7x plus 3. Now some students will want to rewrite this as 4 minus 5x. And that's completely okay if you rewrite that as 4 minus 5x. Either one is fine because you are going to get the same value regardless of which way you write it. Now I need a little bit more room, so I am going to erase over here so that we can finish the problem. Okay, so I'm going to use this. Okay, so I've got, and you'll get the same answer regardless of which ones you use. So I have negative 5x plus 4 equals 0, and then I have 7x plus 3 equals 0. And we are going to get fractions, and I know that we're uncomfortable with fractions, but fractions are part of math. So I'm subtracting 4 from both sides, and I'm left with negative 5x equals negative 4. Then I divide both sides by negative 5. So my answer to my first factor that I set equal to 0 is positive 4/5. And the reason it's positive is a negative is divided by a negative, and that gives me a positive number. Okay? Now, our second factor is 7x plus 3 equals 0. So I'm going to subtract 3 from both sides. And when I do that, I get negative 3. I divide by 7. And so my answer here is negative 3 over 7. So my two answers are 4/5 and negative 3/7. Okay, and so those are kind of, I mean, they're factors, the factor, or they're fractions, but then the factoring was tough too. It was some large numbers for us to deal with. Okay, let's move on to number 21. Okay, number 21 is another one of those that looks like it's already in factored form. However, it's not set equal to 0. So before we can do anything else, we've got to go ahead and multiply this n times 3n minus 5. We've got to multiply that out. So n times 3n is 3n squared. N times negative 5 is minus 5n, and that is equal to 2. So what I need to do now is bring that 2 over so that I can have it set equal to 0. So I'm going to subtract 2 from both sides. So I have 3n squared minus 5n minus 2 equals 0. Okay, now we are looking at a trinomial. Our a value is not 1, so in order to get our product, we have to multiply these two together. So 3 times negative 2, so my product is going to be negative 6. And because my product is negative, that means my one number is going to be positive and one number is going to be negative. My sum here is negative 5. Fortunately, there's not too many different options to get 6. We have 2 times 3, which is probably the first thing that we think about. Now, if both of these were negative, so if I had negative 2 times negative 3, that sum would be negative 5, okay? But negative 2 times negative 3 does not give me a product of negative 6. So I know a lot of you are thinking that negative 2 and negative 3 are the numbers, but it's not. It's actually going to be 6 and 1. So 6 and 1 give me 6. If I make the 6 negative, negative 6 plus 1 is going to give me negative 5. So these are my two numbers right here. Because our a value here isn't 1, then I have to split this middle term. So I'm going to have 3n squared minus 6n minus 1n minus 2. Okay, so I look at what can come out of the first two terms. I look at 3n squared and 6n. A 3 and an n come out of both of those. So I'm left with n minus 2. Now here, I'm actually left with 3n, yeah, that's right, n minus 2. So I have made a mistake. So this should actually be plus. So this should be negative 6n plus 1n. So like I said, you've always got to be careful because you've got to get exactly the same thing. So there is my mistake right there. Hopefully you caught it before I did. Now, I can't take anything greater than 1 out. So I think a lot of times when students see this and they're like, I can't factor anything out, they want to put a 0 there. But you don't put a 0, you put a 1, because 1 times 1n gives me 1n, and 1 times negative 2 gives me negative 2. Okay, so you have to be careful with that. When you don't think that you can take anything out, you're actually taking out a 1. So my two factors are 3n plus 1 and 1n minus 2, and you don't have to have that 1 there. Whoops. Wow, I'm not sure what I just did. All I wanted to do was erase the 1. You certainly could have the 1 there, but it's not necessary. So again, I'm going to need to erase some on the side so I can fit it all on the same screen. So that we can finish factoring, or we can finish this problem. We've already factored. So my next step is to just put each factor equal to 0. So I subtract 1 from both sides. Okay, and then I divide by 3. So one of my answers, or one of my solutions, is negative 1/3. The other solution is going to be positive 2. So my answers here are negative 1/3 and positive 2. Okay, so we have one more problem that we're going to do on your quiz tomorrow. There is not going to be any word problems. So that's a good thing. No word problems tomorrow. Factoring is going to be the thing that you want to really study for tomorrow's quiz. Okay, so I'm going to go ahead and we're going to do 22. This one is not terrible. This one isn't nearly as bad. The thing with this one is that you have to be able to recognize it as a difference of perfect squares. Now, you could solve this problem a couple of different ways. One way, option one, is that you look at this and you say, oh, that's a difference of perfect squares like Alicia was talking about. So 9 is a perfect square. So remember, our perfect squares are 1 times 1, which is 1. 2 times 2, which is 4. So 4 is the perfect square. 3 times 3, which is 9. 9 is the perfect square. 4 times 4 is 16. 16 is the perfect square. 5 times 5 is 25. 25 is the perfect square. 6 times 6 is 36. 36 is the perfect square. So for something to be a difference of perfect square, it has to be subtracted. If it's added, it doesn't work. It has to be subtraction. So you might identify that 9x squared is perfect. And so you would say, okay, the square root of 9x squared is 3x. Okay, then you're like 36 is perfect, and the square root of 36 is 6. And one has to be positive, and one has to be negative. So at this point, you could put each one of them equal to 0, and you could solve. So we have 3x equals negative 6. When I divide by 3, I get x equals negative 2. Here I get 3x equals 6, divide by 3, and I get x equals 2. Okay, so my answers are negative 2 and 2. Okay, that is one way to do it. Okay, and looking at it and identifying it as a difference of perfect squares really is kind of a quick way to do it. Okay, now I'm going to erase all of this and I'm going to show you my second option for this. Okay, so this is going to be option 2. Okay, this is option 2. When I look at 9x squared minus 36 equals 0, I might look at it and say, oh, I have a common factor. 9 is a common factor to both 9x squared and minus 36. So I pull out a 9. And when I do that, I'm left with x squared minus 4 equals 0. Now, you might not have realized that 9x squared minus 36 was a perfect square, but hopefully you did identify that x squared minus 4 was a perfect square. So I can factor x squared minus 4 into x plus 2 and x minus 2. Now, we have 3 factors here. This one right here does not involve an x. So if you want to, you could write 9 equals 0 as one of your things, and then x plus 2 equals 0, and x minus 2 equals 0. But this 9 equals 0, that's just not true, okay? 9 does not equal 0. It doesn't have a variable with it, so this is not something that comes into play when you're trying to find solutions. You just throw it out, because you just get rid of it. Okay, so you don't need to think of that 9 equals 0 as one of your solutions. Then here we end up with x equals negative 2 and x equals 2, which is exactly the same thing that we got when we identified it as a difference of perfect square earlier. Okay, so one of the things that you want to know, one of the things that you want to practice is you have got to practice factoring. Factoring is not going away. So I'm going to give you some extra practice for factoring to work on over the weekend, and I highly, highly recommend that you work on it. Factoring is going to play a very, very key role in what we are doing next, in next chapter. Okay? I will see you guys tomorrow for your quiz.